This is TWIS. This Week in Science, episode number 891, recorded on September 7th, 2022. What is the rain shadow effect? We'll find out about that today on the show. I'm Dr. Kiki. We are going to fill your heads with patience, cannabis, and thick skulls. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. The future isn't here yet. We can't know for certain what it will look like, or what it will sound, smell, or taste like. While we can almost touch it, the future is always just out of reach. Still, one of the things humans are famously good at is planning for the future. Stocking up for winter, planting seeds in spring, investing for the future. It's what separates us from fish, apes, and fruit flies, who famously are terrible at farming. Those stock selections by captive chimpanzees typically beat Wall Street financial speculators. The future, despite all of its not existing yet, is the one thing we all rely on when making decisions. When we fail to consider the future, when we attempt to ignore it, it has a strange way of happening anyway, often with unforeseen consequences. More often with super foreseeable consequences. Because while the future is a mystery, the past and present are not. And at present, we are setting up the future for some very challenging consequences. And at present, science is working hard to overcome the problems of the present. Problems that, if science is successful, won't follow us into the future. What new problems will we have? What old problems will we forget were a thing? Future spoiler alert, This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again, dun, 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 as we are every Wednesday at 8 p.m. Pacific time. Back again to talk about all the science that we enjoyed from the past week. And we do hope you are ready for a great show because we got a lot of stuff to talk about, as usual. So much good science. I have some stories about pollution from you. You making pollution, concussions, and brain regeneration, because that's what we all need. Futures. Yeah. Justin, what do you have?
I've got galling wasp behavior, the downside of cannabis, whose trash is in the ocean, and why fatty foods aren't actually delicious.
Why aren't they? What? I would like to know. And who is throwing trash in the ocean? Justin, these are really good questions.
I have the answers to everything.
Yes.
Good.
Okay, super excited. Yeah. All right, Blair, what's in the animal corner?
Oh, I have albatross blobs, I have drumming chimps, and I have big wet mice.
Big wet mice.
Yeah.
Parties at your house are always so much fun.
Party at Blair's house. This is the Big Wet Mouse Party.
Yeah.
We're all going to have a great time tonight on the show. Okay. Before we jump in, just want to remind everyone that if you are not yet subscribed and this is your first time joining us here, wherever you're joining us, you can subscribe because that's something you do. Hit that big subscribe button. Do that. Hit for the notifications. Make sure you're getting notified every week when we have a new show, Wednesdays, 8 p.m. Pacific time, where we stream live on YouTube, Facebook, and Twitch. And additionally, you can find us on the social medias. We are TWIS Science on Twitter, Instagram, and also on the Twitch. You can find our website, TWIS.org, for all sorts of other information, or if all this information is just too much for your head right now and you want to go find it someplace else later. Our website's a good place for that. Okay. Are we ready? Into the science? Okay.
Good.
Let's jump into the pool, everyone. Okay, let's have a little patience. Yeah, we got to have a little patience with NASA right now with the Artemis 1. This is, in case you hadn't heard, they scrubbed their launch again on Saturday, and they have decided to put it off indefinitely. At least it probably will not make it through the end of this launch window, and they might have to remove it from the launch platform. However, they are going to try and repair what they think is a loose connector in their liquid hydrogen fuel system, where the liquid hydrogen gets into
Hate it when that happens.
Yeah, we all hate it when stuff like that happens, but engineers are working hard. They're going to try and make the system go. And you don't launch if you think you're going to have your rocket explode on you. You just don't want to
No.
do that.
No,
This is
you
something
don't.
we
A
want.
lot of money there. Yeah.
This is a lot of money. Yes, lots of money. And it's also that proof of concept of, hey, we can go to the moon. We can do it. And we can do it safely. So next time we can put people in it.
We can tell when it's going to explode and we won't let people go in.
Yeah. I feel like this is what happens. Like, I feel very akin to NASA right now because I feel like this is what happens whenever I leave the house. In like, I'm leaving at the right time, so I have enough time to go where I want to go. I'm on schedule,
Yep.
and then I realize, oh, I'm not wearing a belt. Where did I put my belt? Then I gotta
Where
go
do
look
I
around
put
for the
that
belt,
thing?
and then I pass the mirror on the way to finding the belt, and I'm like, oh, I didn't shave. Oh, that's terrible. I should go do that. How
And
did I forget that? And then
suddenly,
you're in there and you're brushing your teeth and
and there's no way this
taking a
podcast is
shower, and then you
ever
gotta
happening.
use the restroom. And by the, one thing leads to another, and then eventually, though, you get where you're going, and then you say, "Oh, there was traffic."
There was traffic, exactly.
There's
So
traffic
we
on the
hope-
launch pad.
Yeah, it's traffic on the launch
Sorry.
pad. That's all there is.
and after this, they're working on it. We are still gonna this. It's not like, oh, we're never gonna do it again. There are plenty more launch windows for the Artemis 1 mission this fall, and so hopefully we will be seeing the launch happen this fall, which fingers are crossed it does. And hopefully sooner rather than later. But the big thing is hopefully it happens safely and it's all great. And then hopefully they get everything fixed. But in the meantime, we can keep ourselves patient by basking in the glory of the images that
So awesome.
the James Webb Space,
So much
the
coolness.
JWist, if you would like to not have it named after the dude. Yeah, so much cool stuff. And this time around, NASA has announced their views of the tarantula. This called the Tarantula Nebula. It's a nickname for the appearance of its dusty filaments in previous telescope images, but now with this image that have never been seen, were clouded by the dust and the gas that got in the way of the light that our previous telescopes depended on. And so now, because we're looking at everything in infrared, we're able to see the heat of these hot young stars and be able to see actually what's in there. What's going on in that cosmic nursery? And so there's a whole bunch of stuff happening. They're able to take a look at using the near infrared spectrograph.
This is one of those
There
things
you
where
are.
this is not an art. Like, we're almost used to this image because artists are awesome, and artists have been doing artist renditions of what a nebula would look like
Right.
if we could see it up close and in high resolution. This is not
Yeah.
that. This is the thing. This is it's infrared transferred to the color spectrum, but this is an actual thing, not an artist's
Hey, isn't it?
interpretation of what
Yeah.
a nebula would look like. And that's what's so amazing is
Mhm.
one, how awesome that photo you got up there is, and two, how really good the artists were at at presenting what it would look like, because it looks like a painting.
It does look like a painting, and it's 161,000 light years away in the Large Magellanic Cloud Galaxy. It's the largest and brightest star-forming region in the local group, and this is the group of galaxies that are nearest to our Milky Way. So anyway, they viewed it with the NIRCam, the near-infrared camera, and the region resembles, as the name says, a burrowing tarantula's home, lined with its silk.
I'm not really
Sure.
seeing that, but
Blair.
it's still
Blair
pretty.
says sure.
I like Blair's
I
dust
think-
bunny nebula.
Yeah, no, it looks like a lint trap to me when you did your load of reds, right? That's what it looks like. But I get it. You don't want to call it the lint trap nebula. The tarantula nebula sounds a lot better.
Sure, it does. One of the reasons that this is interesting is it has a similar chemical composition, according to NASA, to the gigantic star-forming regions observed at the universe's cosmic noon, which is when our universe was only a few billion years old, but star formation was really getting going and at its peak. We weren't really there yet. But yes, it's very exciting. We can look at these beautiful images all day long, and I invite you all to go to search NASA's TWIS gallery of images, the full resolution images that have been worked on by the web production team and other artists to help allow us to really see this infrared data in its full color, glory, and light. They're very beautiful images. Justin, what do you want to talk about next?
I got some breaking science news from 2 years ago. An 8-year-old.
That's not this week.
Well, the study was published this week.
Okay, all right, good. Okay, go ahead, proceed.
It started 2 years ago when an 8-year-old named Hugo turned over a log while playing in his backyard and discovered an ant's nest. While this scenario is often followed by an adolescent experimenting in playing almighty decider of fates for ant minions, Hugo took a more insightful approach, observing small spheres he thought might be seeds. Thinking it odd that ants were collecting seeds, behavior he had not encountered before, he brought the observation to the attention of his father, who happened to be a professor of entomology at Penn State. Hugo's father immediately identified the objects as oak galls. These are growths that are triggered by wasps on oak trees to create little baby wasp houses. And there's some wasp species induce oak trees to produce these productive growths around their larvae for safekeeping. But what were the ants doing with them? There are some plants that are known to produce edible appendages to their seeds, and these little edible appendages attract ants, which then the ants take those seeds and they bring them back to the nest, thus dispersing the seeds further away from the plant than the plant could have gotten them on its own, eating the appendages and then just leaving the seeds to grow in that new location. But galls contain wasp larvae, not the seeds. So what was going on? Galls normally do have a little fleshy pink cap. The galls near the ant nest did not have these caps, suggesting that maybe they were eaten by the ants. According to Hugo's father, ultimately this led us to discover that gull wasps are manipulating oaks to produce galls, and then taking another step and manipulating ants to retrieve the galls into their nests, where the wasp larvae may be even more protected from predators who will eat the galls themselves.
And then when they hatch,
then they might even maybe have a couple of ant snacks lying around. According to Hugo's dad, this multi-layer interaction is mind-blowing. It's almost hard to wrap your mind around it, and had not been observed. So that we've known about the gall and the plant behaviors for centuries. We've known this, but this ants collecting galls has never been seen before. Little Hugo.
Wow.
8-year-old
Cool.
Hugo discovered.
I really appreciate your calling it Hugo's study, and then you talked about Hugo's dad, who's probably actually the person who published it, but that's totally great. I love that.
Yeah, well, this
Hugo's
is,
study.
you go with the person who made the discoveries. That's fine.
Yeah.
Great. So the team's findings published in the journal American Naturalist, link on our website to better find it. So to better understand the interaction, Hugo's dad and other researchers conducted a series of field and laboratory experiments. They observed ants transporting galls to nests. Within the nests, all the edible caps were removed, then and eaten. The galls themselves, the little containers made of oak tree growth with the baby wasp larvae in them, those remained intact. And they even did a bunch of tests. They set up, to see if it was just the galls that would be taken. The ants would transport galls without the caps, but they definitely had a stronger preference for the ones that had the little edible cap. And they also used some of those plants that have the little edible appendage to them. And they found no preference difference between the galls and the plant seeds. Further delving in, they've discovered that there were fatty acids on both, which they knew were on the seeds, but the same type of fatty acids were found on the gall caps. And when the plant creates it, they think it's to mimic the scent of a dead insect, which then induces the ants to take them back to their nest and eat them. And the same thing is going on with the wasp gall caps. They also are mimicking the sort of scent of a dead insect or the chemical makeup of a dead insect. So you have this amazing convergent sort of evolution thing going on where both a plant and a wasp are using a very similar strategy to get ants to do work for them. So which came first? The gall or the seed? And just because of the sheer abundance, especially in the past, of oak galls, and because there's a lot more of it, and they can go back thousands of years, they think galls the wasp activity may have come first, and then the plants might have lucked into or selected into getting this behavior, but they don't really know at this point. But anyway, super interesting, great observation, Hugo, and and like Blair was saying, props to Hugo's dad too for doing the follow-up study.
Yeah, for like publishing and all of it.
Yeah,
absolutely. Yeah. The fun aspect of this is it's kind of chicken or the egg, which came first evolutionarily, and how can we?
Egg. Well, if you're talking about evolution, it's the egg.
I know, always egg. You always go. I know.
Dinosaurs have eggs.
Now it's just idiomatic speech. Okay, but anyway, kind of which came first?
Did you call me?
Which came first, the caudal vertebrate or the egg? Which came first, the multicellular organism or the egg?
And in this case, which was it? Was it the wasps? Was it the galls? Was it which made it happen first? But ants really like doing the work, so it doesn't really matter. They're just happy.
They love doing work.
I got some work, and I'm going to take it back to my nest, and then there we go.
Yeah, and in a sense, you could actually say it's the ants that are doing all the selecting in this. Wasps may have lucked into a thing. Plants may have lucked into a thing or happened into a thing, and ants turned it into their survival strategy turned it into a survival strategy for plants and for wasps to continue these behaviors because of ant farming. Ants are good farmers. They are great farmers. Yep. They've been cultivating this planet a long time.
Moving on from farmers, we're going to go to citizen scientists. Blair.
Yes. I want to talk about the British Antarctic Survey, and that they are now looking and recruiting for citizen scientists to count albatrosses.
Oh.
Yes, and so I just wanted to talk about this citizen science project because it's pretty cool. It's
in
about
Antarctica?
Yes.
No.
Yes, and no. But you can do it right from your own chair. So
Aha.
here we go. So
Oh,
the albatrosses
do
are,
explain.
it's,
Yeah.
yes. So they're searching for wandering albatrosses via satellite imagery taken from space. They want to see what current population levels are. They want to see potential impacts from climate change, fishing, invasive species. Albatrosses are an important species to follow for a bunch of reasons. They are pretty heavily impacted, but they're also really important to various ecosystems. The Albatrosses from Space Project, which is what this is called, is focusing on wandering albatrosses in South Georgia, which is in the South Atlantic Ocean. Normally, albatrosses will nest in grassy, flat terrain, but these islands have sheer rocky cliffs and outcrops, so they're extremely dangerous for people to explore on foot. So by using satellite imagery, they can count the birds safer, there's no disturbance to the birds or their habitat, saves time, saves funding, and it opens up completely inaccessible areas for surveillance. They're currently only looking at one of the islands, but there are over 20 breeding sites in that area. I'm sorry, they're looking at 3 sites of the 20, but so this could help them cover the other 17. They've been using satellite images to detect albatrosses for many years, but it's never been at this scale. That's because they figured out that because the wingspan of a wandering albatross is over 3 meters, it's the largest of any living bird, they can be picked up on satellite images. They appear as creamy white dots. And so you can go through these high resolution satellite images and count albatrosses for them. You don't need to be an expert. They walk you through exactly how to do it, and they hope to complete the first worldwide albatross census through the the Albatross from Space project. And so Kiki is sharing the site right now, but if you go to the British Antarctic Survey, you could even Google it, British Antarctic Survey Albatross Space Project. You can go right there, click a couple links, log into a site, and you can start counting albatrosses. So
Wow.
I encourage anyone who has some time to go help count some albatrosses. But I just want to bring this up. We talk about citizen science citizen silence. It's the opposite of that. Citizen
Don't
science.
be silent. Do the science. Yeah.
It's removing the silence from the scientific field.
Yeah.
But anyway, I love talking about citizen science. We do it a lot on the show, but in particular, I really think it's important to recognize that all of these at the tips of your fingers, but previously remote monitoring that is out there for us to participate in means we, in the next couple decades, I think are going to see some really amazing findings come across our desk. So I look forward to the next 20 years of TWIS because we'll be able to see some of the benefits from these wide scale citizen science projects where all you need is internet. So yeah, go count some albatrosses and help give to this worldwide census project, and we can help protect albatrosses, see trends as they develop, and save their ecosystems as well.
Very
I
cool.
think yeah, that's so neat. Especially, I mean, looking at these images, you're going to have to learn how to identify
Yes.
these albatrosses because,
Yeah.
like you said, they look like little dots.
Yep.
3 meters from space might be
But
it's
3
a large
meters?
animal, but it's still you got to
3
learn what that
meters is the
signature is.
wingspan?
Yes.
That's
Yep.
amazing. That's way bigger than I thought they were. I've obviously never seen one in person.
I went to an albatross soiree by NOAA. It was being held by NOAA and some other people. And the National Farallones Marine Sanctuary. I'm missing words. But anyway, I went to the albatross soiree and they had a sample albatross wingspan, and you got to go up to it and put your arms out. And you can go find it on my Instagram at Blair Beth. There's a picture of Brian in front of it, and it's huge. It's so cool.
That's wild.
Yeah.
These birds are amazing. They leave their chicks and they go wandering out over the oceans for days, weeks. Hundreds of thousands of miles of just soaring. They're made to soar.
They're long haulers for sure.
Yep. Amazing birds. Amazing sense of smell as well. And speaking of the air and soaring through the air, speaking of the air, humans were bad for the air. And not just because we pollute and we throw lots of pollutants from our smokestacks and tailpipes into the air, but our skin is actually...
Oh, she's making us anticipate the next thing.
Our skin is actually...
Our skin. That's what we heard.
Our skin creates toxic airborne chemicals. It actually reacts with ozone to produce reactive molecules in the air that are bad for us and actually increase indoor air pollution. So air pollution is a global threat. Indoor air pollution is one of the biggest threats, and this international collaboration between atmospheric chemists and engineers showed that the oil in our skin reacts with ozone to create free radicals. And those free radicals then can react with organic compounds and turn into pollutants that are bad. This was published in Science this last week, and it is part of a suite of experiments that are on the way to determine how humans impact the environments we inhabit just by being in them.
Yeah, and it's an interesting story too, because that wasn't supposed to be a problem. It wasn't supposed to be a thing. But one of the I guess the thing that sunlight does that's good, you get a little sunlight on something and it cleans it. Like, part of the problem is in these indoor environments too is that we have isolated ourselves away from sunlight. Even having the tinted windows or infrared windows or whatever they are that kind of don't allow as much sunlight into a room prevents sunlight from breaking down ozone and creating the indoor ozone. You got to open up the windows, let the sunlight in.
And that's exactly what they recommend. Yeah, that is exactly part of the recommendations is, getting air exchange and that indoor air exchange and management should be something that is more is a bigger focus. And we're looking now at like 20 years of indoor air. And since the World Health Organization put out a big statement saying we need to worry about indoor air and take care of it, and it was like a declaration of clean indoor air for people in indoor environments that nobody's paid attention to whatsoever. So here we are figuring this out right now.
Especially in a post aerosolized pandemic time. That airflow indoors also seems like a really good idea. Now, my hometown has gone through, I think, a week or two of triple-digit heat.
Yeah, the West Coast is just boiling, burning.
And so nobody there cares about the quality of the air right now. They want it isolated from the world, and they want it cooled down dramatically. But for the rest of the year, having that good air exchange with the outside, that's something that it's amazing that we haven't spent more time focused on.
The fun thing about this study is how they actually did the work. They got individuals to actually just sit in a chamber with 3 others. So if there were 4 individuals, and they sat in a chamber that was climate controlled, stainless steel, on separate days for as long as about 5 hours. And the researchers measured the changes in the amount of organic compounds and hydroxyl radicals. And they looked at the composition, and they had everybody breathe into special masks. So they look like they're like scuba divers, but they're just sitting in this stainless steel isolation chamber. So it's a very like I guess future punk kind of Brave New World kind of image.
That's great. We're gonna need your help for this study. You can play on your phone the whole time. You don't have to do anything really. Just sit in this room and wear this weird mask.
Yep. Yep. But they did so because they knew that the mask was working and they were able to check what was going on with the chemist, know that the breath had nothing to do with what was happening in the chamber. And so everything else in the chamber was likely coming from the skin. And
Where
I guess
was
there's
this?
a possibility for where it could be coming from, but I don't know if they looked at that if they looked at that as well. What did you want to know?
Oh, where is this study from again? Sorry.
This study was from the let's see, they collaborated with researchers at the University of California, Irvine, Penn State University. This is also, um, yeah, let's see, yeah, Cyprus Institute and the Max Planck Institute for Chemistry in Germany.
Okay.
So, bunch of different research organizations, institutions working
Yeah, our
together.
former guest, Jonathan Eisen,
Yes,
uh,
yeah, from UC
was
Davis.
from UC Davis. Has also been, he's a biological, evolution and ecology professor there. But he's also been starting to focus on in-home environmental issues as well. So I think this is one of those. Okay, with scientists, you look under your nose and you may find undiscovered territory, which is what's so amazing about this is that we're out there in the field studying biomes and nature and outdoors in the cities and figuring everything. Then we go home and think, all that is out there that
Yeah.
I study. And then at some point, somebody realizes, actually, this is an environment that I'm sitting in right now, different from all of those other places that I've studied. Yeah. About time we started looking at.
Well, if that's the case, we don't want things too different. We just gotta chill. So maybe you could bring the cannabis into the show right now, Justin.
As well, so this is not a story about necessarily positives though. With all the legalization of cannabis and the related products these days, there's renewed interest in researching potential medical uses, but there's a major downside to all this increased cannabis use and availability that has been tragically overlooked. It seems now that we are starting to, based on this study, find that all of this cannabis is reducing our dependency on conventional pharmaceutical drugs. And it's hurting the pharmaceutical industry.
Oh,
Which-
shucks.
Yeah, I
Right. Some
know.
people wouldn't say that's a bad thing.
Well, but
It's-
then
I
those
mean,
people
they've
don't
always-
work for the pharmaceutical industry.
They've always taken such good care of us and
They
never
have.
taken advantage.
No, not
I'm
once.
so sad.
As somebody who's hoping that we get a sponsor at some point, I'm going to be very careful in saying the pharmaceutical company only has our best interests at heart all of the time. But that aside, that shilling aside, and a study published in PLOS One and available via link on our website, researchers from California Polytechnic State University and the University of New Mexico studied how the stock market returns of publicly traded pharmaceutical firms respond to medical and recreational cannabis legalization events. They found stock market returns were 1.5% to 2% lower 10 days following the cannabis legalization events, and that the implications of the annual sales from this reduction were in the billions. So they're using the stock market because there are studies already that have determined that cannabis access reduces consumption of specific types of medications, such as opioids, which has been a thing. It also and it's also there's reduces pharmaceutical use in certain types of medical patients, specifically Medicaid patients. They found reduced their pharmaceutical use when they had access to cannabis. But this study looked at analyzed the overall effect of cannabis on pharmaceutical firms across all products and all types of patients. Most drugs, which are designed to target and are first approved for specific conditions, and then only then later are there attempts to expand the specific target to more off-label uses to get a wider audience for the drug. Cannabis is a very surprising drug in that it's already used to treat an astonishing range of conditions, from physical symptoms. People who get like migraines will use it. People who have muscle spasms, back problems, that sort of thing will use it as a pain relief. Also, it is used for mental conditions, depression, anxiety. People are using it for all sorts of things that there are already specific drugs from the pharmaceutical companies on the market that they're supposed to be handling. While the cost of pharmaceutical drugs uh, is never exploitative, and it can be somehow, according to this a study, a significant financial burden to individual states and the federal government. I don't understand how that's possible, but cannabis, in contrast, is exceedingly cheap, easy to manufacture by comparison. Current study concludes that cannabis acts as a new competitor across drug markets. Extrapolating the results to full federal legalization, the authors estimate a reduction in conventional pharmaceutical sales across industry of almost 11%.
That's substantial. I mean, that's huge.
Right. That's huge for one drug that we've already had.
But that was illegal for a very long time and has only recently been made medically legal. I mean, it's really only recent.
And it doesn't make you think that there was any, war on drug related to marijuana that had any sort of pharmaceutical company backing, because that would
that never happened. That never happened.
Across, I mean, that is so that like your early 1990s pot dealer who was dealing marijuana, out of a fanny pack, eventually moved to drop the pharmaceutical industry by 11%. That product was that. No wonder he's stayed in business. So they say substitution away from conventional drugs towards cannabis appears to be occurring, even though we don't have standardization of dosing or health insurance coverage or clear doctor's recommendations at this point. And they also point out that it might be difficult to get to that stage, because there's this idea that, okay, what we need to do is isolate all the components of cannabis, from THC to CBD, and then figure out what specific targets to put them to, and then isolate it and quantify it.
And then suddenly it's the pharmaceutical industry again.
Well, there's that, but then there's also, they're saying, like, part of the thing with this plant is that it is such that it's we are familiar with THC and CBD because those are talked about a lot, but they're part of a big host of these reactive chemicals in there, cannabinoids that are in, and it's such a broad swath of interactions, and it can, there's plant diversity and other things involved too, that they're like, by the time we get to isolation, people will already be probably comfortable with how they're approaching it. That's going to be a whole thing unto itself. So anyway, in addition to their overall findings that cannabis legalization decreases the stock market value of publicly traded pharmaceutical firms, the authors found that recreational legalization had more than twice the impact of medical legalization. And they think that's because more people are having access to it. They seem to think that there was a high bar for getting one of those medical cards. I don't know how true that was.
No, but I think there was still a lot of stigma that would prevent people from partaking before there was full legalization. Because if you felt like it could be scrutinized, your reasoning for having the medical card or anything like that, it could put your employment into question. There's lots of things that can happen from that before you go full legalization. And it kind of makes it feel more okay culturally, I think, too, for you to try it and go, okay, yes, this works for me. I'm going to use this habitually for this one thing or whatever.
And it's one less step. You don't need to go to the doctor and get a doctor's permission before you go to the dispensary to find, what you need. You can go figure it out. And, so the recreational side, I think people have been for a very long time taking care of their pain, taking care of their
Yes.
migraines, like you said,
Certainly.
taking care of nausea. There have been
Mhm.
lots of uses.
Anxiety.
Anxiety.
Well, and that's the thing too.
Yeah.
It's like there's something out there that we were talking about a few weeks back that and it was an Australian study, but they were talking about how it was approximately a third of teenagers are dealing with some form of an anxiety disorder. And it's
Right.
sort of like that's sort of when marijuana becomes a very interesting thing.
Did you say a
Except that,
third?
except that marijuana is not
Third,
recommended for teenagers
Right.
because
Their
it
brain.
actually it changes the way that the brain
Oh
structures
yeah, yeah. Oh, just say no, kids.
lead
Just say
to
no. Just say no.
anxiety and
Yeah, don't do drugs.
other mental issues. So there have been
Yeah,
studies
never
that
seen
shown that
it.
it's not great for teenagers. But
The
anyways,
thing I
never
was going
seen
to
it.
say is
However,
when you said a third, I actually
Yeah.
think that's low for teenagers and anxiety, right? There's
It-
so much
well,
to be anxious about. There's
it
so much
might have been
happening in your
2/3.
body, like all this kind of
Might
thing.
have been
But
2/3.
so what I was going to say is the other thing about marijuana use with teens is that like this is a formative time when you have to teach yourself how to deal with stress and anxiety and all these other things. And if you end up using something like this, just like you might use an over-the-counter medication to just kind of like, I think that's the big difference with using recreational marijuana to treat medical problems versus, in theory, if you're going the medical route for marijuana, then you're talking to a doctor about how to use it and when to use it and how to get other ways of taking care of these things you need in addition. But if you go full recreational, then you don't kind of have that holistic conversation as often.
So what we're talking about though
But-
is in the perfect world. What I'm
Yes,
just
of course,
mentioning,
of
what I'm just throwing out is undiagnosed, ignored. Just grow up, kid, and deal with
Mhm.
life. Life is
Right,
hard. You're
right.
a teenager now. Deal with it.
Yeah.
For generations, teenagers have been figuring out like, hey, this makes me feel better.
yeah,
And so it's self-medication.
everyone
which
can find
self-medicating
band-aids. Yep.
is as opposed to right. Anyway, I'm just saying the undiagnosed anxiety and then the tendency for teenagers to get interested in this thing might not be a coincidence. That's all. Not a recommendation. I actually personally don't like it, but I also have anti-anxiety problems. But
Same
this
here.
is also
Can't even. I'm like, you want to make me anxious? Yeah, no.
the last finding was that they found that branded drug manufacturers were more affected than generic manufacturers, and they think it's because there's a greater competitive impact on cannabis on drugs that don't have existing competitors. That they're actually
Right.
they actually compete really hard against new drugs that are just coming out by pharmaceutical companies, which I think is hilarious for a 12,000-year-old plant that's been with it.
Yeah.
All I hope is that it will replace things like the opiates that have
Yes.
been a
That would be
real
ideal.
thanks to the pharmaceutical industry.
That's also where it's having the hardest time getting legalized. I wonder why.
Yep. Sometimes, you feel maybe like your brain's not working. We talk a lot about brain fog these days, but when it is caused by actual physical damage, a concussion, that damage can really be long term. We've been talking a lot about how concussions can affect people and lead to traumatic brain injury over long periods of time, which can lead to all sorts of health issues and mental health issues as people age, especially if there are multiple concussions. But one thing that people have not really looked at with regard to concussions is the skull itself. So we've talked before about new football helmets and how they try and make the football helmets, able to spread force around, make the brain slosh around inside the skull a little bit less upon impact. But what
you
really
need
happens?
to do is you need to line the inside of the skull with something squishy.
Right? Well, researchers at Monash University have published in Scientific Reports this week their study of the skull and repeated concussions. And they have reported that when you get more concussions, your skull gets thicker. So the skull responds
No.
to impacts
Mhm.
by thickening itself. Now the
That's how
question
bones
is,
work, right?
it is right, repairing damage, right? Trying to strengthen itself for
Yes.
future impacts.
Which way does it get thicker? On the outside or on the inside?
So it the bones structurally reinforce themselves on the inside for these impacts.
Oh no. The wrong side. Dang it.
But they're not sure whether or not this is a good thing or a bad thing. Because what does it really mean? Is it really going to help your brain if your skull is thicker? Does it
On the
help?
inside, it's taking up more space. What if it's got
Yeah,
a
so if your
pointy part?
brain is swelling, then there's less space for your brain.
Oh, jeez.
Right. So there are more. They've got more bone cells. They find that, and of course, this was not in humans. This was a mouse, a rat study where they impacted rat heads, and then looked to see what the rat skulls were doing. But they found, there are these intervals. They grew, that they were thicker. The bones were growing from the inside and pushing outward. So that would
Yikes.
mean less room necessarily on the inside for the brain tissue, for the swelling brain tissue. But what does that mean for the next time around? We don't know. Does this mean that it's like your brain's getting more like a football helmet? Is that what your skull is anyway? No, we don't know this. So, yeah, but anyway.
That's all interesting, but I really want to. Now, what I want to know is how they taught those rats to play football. When you get all the tiny helmets.
Yeah.
Go rats, go.
Do they have to wear 4 sets of shoulder pads? How does that work? 2 sets? I got 2 sets.
I don't think that's exactly how it worked.
No.
But anyway.
That's probably more fun than what they actually did, so keep thinking about that.
Got it, but that's why.
Keep thinking about little rats playing football.
Yeah.
This is why I don't have anxiety.
Instead of scientists concussing rats over and over in some other way.
Yeah, this is why I entirely lack anxiety, is because my brain feels in a happier solution.
Oh, boy.
All the problems of the world. I don't know, let's picture it different.
Yeah, potentially with if you're thickening the bone and there's less room for bone marrow, that means there are fewer cavities, there's more structural integrity possibly. It's a very interesting question. Is the skull thickening important? Is it good? Is it bad? It is what happens. So now we have more questions to ask.
Yeah, and this is important work, and I am excited to hear more about it. But also, I'm just going to throw out there one more cry to maybe stop intentionally concussing ourselves when it is not required.
Yeah, maybe we could stop throwing our heads at each other or throwing our heads at immovable objects. Might be.
I totally agree with all of that. Although football isn't going away. I don't know if anybody's noticed.
No,
but
I know,
it's
and
not
that's why
going
this
away.
is important. But I'm just saying it's.
It's
just a shame.
Well, there's one of those things too. Is like some cannabis products are being researched for concussion recovery, for everything from brain power to inflammation reduction. And it's one of those things that has been illegal in sports, which doesn't seem like a competitive edge to like an athlete anyway. If they're having a cannabis product gummy thing on their weekend, but it's another reason why we should not have made something illegal without researching it first.
Yeah,
anyway.
Yeah. So anyway, these researchers are going to be looking at whether or not a thickened skull that comes from repeated concussions is going to alter transmission of force through the skull and to the brain. And so, we may one day know But yeah, we know repeated concussions are bad, but maybe they become less bad over time. Who knows?
I think that's exactly what CTE is. The C in that is chronic, and I think
Traumatic.
so far
Exactly.
our understanding is that it's bad.
It's bad. So far it's just bad. I don't think there's anything that's going to
It would be
make
a pretty surprising reversal if we were like, actually, more concussions is good.
fine, everyone.
That would change school a lot.
Yeah.
Great.
All right, everybody, we need you to. We're going to start off the day by banging our heads against the desk. Ready?
No, don't do that. This is TWIS. Put on your helmets, everyone. I mean, the learning helmets, the ones with the electrodes that stimulate your brain. Oh, wait, you don't need the electrodes because you have us. We hope that we are stimulating your brain just a little bit. And if we are, please take a little time to head over to twis.org and click on the Patreon link, because that is how we fund this show. So if you are able and willing and you love this show, become a supporter of This Week in Science. Head over to twis.org, click the Patreon link, and choose your level of support, $10 and more, and we will thank you by name at the end of the show. I really do love that part of the show, reading everyone's names off for everyone out there. We can't do the show without you. Thank you for your support. Now we're going to come back to a lovely portion of the show filled with, I guess, drum beats this week. Lots of percussioning. That's right.
Yes.
Fantastic.
Animal. It's Blair's Animal Corner.
With Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels, there's Animal Corner.
What you got, Blair?
I have some drumming chimpanzees.
Bump bump.
Yes, so this is in the Ugandan rainforest, and while chimpanzees drumming on roots in the rainforest has actually been known about for a while, I don't know about it, but I guess they've known about it at least since 2011, but maybe since before that. I don't know.
Maybe.
We've known that chimpanzees drum. Okay. So what's new about this research is that not only do chimpanzees have their own styles of drumming on these roots, but also they can hide their signature sound at will to not reveal the location. So they'll still drum, but they'll drum not like themselves if they don't want other chimps to know where they are.
Wait. So hold on. Are you telling me that these chimpanzees are drumming like other chimpanzees?
Yeah. So
I'm going to drum like Ringo today.
This is the kind of the extrapolation and the
John
story
Bonham
that
is
is
who
told from this finding. So let's talk about what actually they saw. So this was the Waibira chimpanzee group in western Uganda's Budongo forest. Researchers recorded the drum sessions of 7 male chimps and analyzed the intervals between beats. Mostly they use their feet, but also they will use their hands sometimes to make the sound. It's so loud, it goes about 1 kilometer away, so it's really helpful for communicating with each other. They use it as a social communication. They wrote the kind of social media, but I feel like that is very widely used now when we talk about animals. Really, it's just communication, right? They're communicating. They're saying, I'm over here. And that allows traveling chimps to communicate with each other. After just a few weeks in the rainforest, PhD student Vesta Eluteri, was the lead author of this study, said that she started being able to recognize who was drumming after just a few weeks following this troop. So on one side, there would be one chimp, Tristan, who she said his hard-hitting drumming was akin to the drummer of Led Zeppelin. It was so fast that you could barely see his hands.
Ah.
But other chimps, like Alf or Isla, would make a more syncopated rhythm. So they would do something in which both their feet hit the root at almost the exact same time, and it almost sounded more jazzy. And so it wasn't until this study that they understood that they're using signature styles while they're looking for other individuals. While they're traveling, they're kind of going through and saying like Marco Polo, basically, with their chimp beats, their drumming beats, to kind of tell other chimps in the area where they are. Sometimes the chimps would choose to not drum in their signature beat, and the researchers believe it was to avoid revealing their location or their identity. Of course, a lot more research needs to be done on this, because for that last bit, I think that is a huge, huge thing to attest in this moment, that they are intentionally drumming differently.
Yeah.
So you need to look at more than 7 individuals for sure. But on top of that, you need to look at the social situation in which they do that and see consistency over a bigger study over a longer period of time. I'm not saying it's not possible. Totally sounds like something a chimp can do. But I will believe it when there is a little bit more data behind it in this case. I think it's a good hypothesis. I will put it that way. But I do absolutely believe that individual chimps have individual styles in the way that they drum. And I love it.
I wonder though, I mean, another hypothesis would be, you know, they have their signature style, but maybe every once in a while they like to try something new. Maybe they are trying, just experimenting. Maybe they're playing. Maybe they, you know, maybe there are, you know, we have so much more to look into, because these are highly intelligent primates. Yeah.
And
So
I want to
there's a
know
lot
if they
to
duet. I want to know if they're like riffing off each other, you know? And so I bring this up also because music is a form of art.
Yep.
And so I wanted to bring this up in that other conversation that we have so often about art being something that is uniquely human, and that if chimpanzees are making music for fun or for communication, that is something to be looked at as a form of creativity and a form of art in an animal species. And also, usually with the apes, we find things that animals are doing, and then when you start looking, you broaden where you're looking in the animal kingdom, you can see more of it the further you look. I would not be surprised if there are other drummers out there that have their own style in different species.
And even if it is a form of communication, hey, here I am, you know, we know in birds, there are birds that can have unique songs. And so then maybe it is a bit of creativity. Maybe there is a bit of nuance and a bit of extra in there. But yeah, for chimps, I love the idea that there's jazzy chimps and there's like rock star chimps.
Yeah, and so that's the next step for this research for this group of researchers. They plan to investigate how neighboring and far-off communities of chimps drum in differing styles. Because if this is in fact a piece of what they want to call chimp culture, then there can be cultural differences based on geographical location, which would be so cool to see that chimps in Uganda in this rainforest do it this way, and then, you know, elsewhere, you know, it's just like different. Is it different countries? Is it different rainforests? Or is it different just like a kilometer away? Is it different, right? Like how much space creates new cultural differences in musical styling?
And is there any, you know, depending on the bass, the amount of bass notes, how deep are the notes they're able to get off of the trees? And does that allow them to have more long distance, if it is communication?
All about that bass.
It's all about that bass,
So what I would actually be interested in finding is if we did find one chimp colony that's doing the drumming, and then it's creating, like, getting worms or something to come out of the ground, or getting insects to leave their habitat, and then you see, oh, here's how this started. This is the thing where they would drum on the tree root thing, and then now they're getting food out of it.
Oh,
And then it
interesting. Yeah.
became a cultural thing that chimps are doing just because it's fun without getting a reward. Because
Right.
that's what then you've got that transition from a survival strategy into a thing you just do because it's fun. And
Yeah.
that's kind of an exciting. That's like a birth of recreational art.
Yeah.
Yeah.
That's awesome.
Let's look into this more. More chimp
Yes.
drumming.
Yes. Well, from drumming, I bring you to big wet mice.
Oh, always the big wet mouse on
Yes.
the Oh,
Yes.
okay.
Is the big wet mouse on the west side of the mountain or the east? That's what this story is really about. In fact, this is about a new rule that we can add to the rain shadow effect, which is why I was so excited to talk about this today, because it was something that I loved studying in zoology, specifically in ecology classes in college. So
West side.
this is
Can I pick one?
Yeah.
Can I guess? I'm saying it's the west side mouse is the wetter one. That's
well,
gonna be
it
my
depends
guess.
also where you are. There's a lot going on, right? So this is specifically the Andes Mountains in Patagonia. So does that change your answer, Justin, or is it the same?
Oh well, yeah, because then everything's upside down.
You had it right the first time. So this was this is a study looking at mice from the western side of the mountains versus the east side of the mountains. So this is specifically the shaggy, soft-haired mice, Abrothrix hirta. And this is from a researcher working on his doctoral thesis. Pablo Teta of the Museo Argentino de Ciencias Naturales. Bernardino well, I'm not done. Bernardino Rivadavia in Buenos Aires. I took a breath in between. That was a very long college name. It's in Buenos Aires. It's fine. But Pablo began studying this shaggy, soft-haired mice as part of his thesis. And he saw that some individuals of the species were big, some of them were really small. He assumed
they're all very cute.
They are very cute. He assumed they were all different species because the size difference was drastic. So he did a mitochondrial DNA study. What did he find? They're the same species.
So one's just male and one's female, right?
No.
No. Okay.
No, in fact,
Oh.
one is on the west side and one is on the east side of this mountain. That is the only difference. So there was a drastic size difference between the west and the east sides of this mountain. So first, they made a lot of they had a lot of ideas why this might be. Does it have to do with latitude? Does it have to do with longitude? Does it have to do with like a million other things? In fact, they tested 9 bioclimatic, temperature, or precipitation variables. They used statistical analysis to compare the measurements of 450 skulls of mice. And then they tried to map them onto these 19 different biological rules to see if they fit known ecological rules for how, for example, the further you go towards the poles, a lot of the times larger mammals are larger, because as you go closer to the poles, it is colder, and the larger animals fare better in the cold. Similarly, if you move up in elevation, animals get smaller because oxygen is less available. So looking at rules like this that are known, proven ecological rules, they wanted to see what the variable was to cause this huge difference in these two populations of mice. None of them worked. The only thing that they saw was that how far east or far west they lived was a very clear definition. So this suggested to them that it had to do with the rain shadow effect. The rain shadow effect is a result of the way water vapor travels over mountain ranges. So you don't think about it, but you have this huge difference in altitude, and one side of the mountain is near a coast and the other side is not. The water from the coastline, from the ocean, it gets pulled into the air, it evaporates. And as
you're going up and up to the mountains, right?
so it evaporates over the ocean. The ocean water evaporates into water vapor, into the clouds. The clouds move towards the land. And as they do that, they are pushed up in elevation. And as it goes high enough, it gets colder, which causes precipitation. And if a mountain is tall enough, the clouds run out before you get to the other side. And so you can
prime example of that in our native territory there is California. Lush green forests right up to the this peak of the Sierras, and then the east side is the Nevada, Utah. There's desert.
It's
just desert. All the water drops in California, and we don't leave anything for our neighboring states because we got that Sierra mountain range, which is why I picked west. Which is why I picked west for the big
right. But it depends which side of the country you were on. If you were looking at a mountain range that was closer to the East Coast, then it would be the east side, right? So it depends. It also depends on air currents. It depends on many things. But the thing about this is what you're describing is hundreds of miles, right? And so sometimes when you have a mountain range that is very close to the water, and that mountain range is extremely steep, you have an extremely drastic difference. You have a lush, productive area on the wet side. Yeah. And then on the dry side, it is dry. It is still usually very cold because you're looking at a mountain still, but it is a dry desert, even though it's cold. Deserts can be cold. So this is the rain shadow effect. What these researchers are suggesting is that there is a new rule that could be added to ecological textbooks someday after further study. This is just one species, right? You have to really see this is across the animal kingdom, or at least across mammals. If this is consistent, then this could be a new addition to the rain shadow effect, that it could impact animal size. So their findings were that shaggy, soft-haired mice and potentially other fellow mammals have larger body size on the kind of the more productive side.
On the rain side. Yeah.
Yes, on the rain side, because of essentially resources. So the rule that they pointed to for this is the resource rule that suggests that where there are more resources, individuals from the same species can be larger than when there are fewer resources. So this rule, when they looked at the rain shadow effect and they mapped the statistics on that, it worked perfectly. So this is the first time, as far as they know, that anyone has demonstrated the effects of rain shadow on mammal size, this very specific thing. And so they hope that they have found a more overall truth that could help also with predicting impacts of climate change and determining future resource availability for animals and for us. This could impact our own resource availabilities based on recognizing how the rain shadow effect works and how that can impact resource availability.
It's going to lead to even smaller mice. No, they'll be so tiny. No, but the other thing that besides resources that it makes me think is that if it's cooler, because it's more humid and you have more rain, you have more cold, you have more snow, possibly being larger is better for warm, potentially, that you can have more body fat if you have those resources to maintain it. Whereas like on the other side of being small, if it's hotter, you can just be like, I get rid of that heat and it's no problem. You have small surface area, and being smaller might actually be better in that situation as well.
Yeah, no, absolutely. And of course, this also is a reminder that if an animal is a mountain species, then as climate change happens, they have to move further in elevation. And so they actually end up with less space, which means if they are used to being very nutrient and resource rich, moving into more competition for space and resources is always going to be a huge problem. And so on the other side of the mountain, they might actually do better because they're used to scarcity, and they have different tactics to get around scarcity. But the ones on the side that are used to, being fat and happy might have more challenges.
Or they'll be the big bullies. We don't know.
Right.
There's so
Right.
much to see how this plays
Yeah.
out. I would really also love, because we know that there are subspecies and different populations of birds like white-crowned sparrows that have that travel up and down mountain ranges for different times of the year. But if the top, like the Andes, this is 10,000, 15,000 feet. This is going to be a barrier to something like a sparrow traveling potentially. So would this even persist as a rule for birds who maybe
Right.
are a little bit more mobile, but still stay within these kinds of ecosystems? So I would love to see if that is true as well there.
Yeah, and if we're talking specifically about body size, you have to look at a lot smaller measurements too, because there's so much less room for error with bird size and still being able to fly. So it's like very specific body plans that allow for very specific flight. So
that's true, but you just measure those little thingies. You just get, what's your wingspan? How much you weigh? How you doing?
We'll start
there,
with the mammals. We'll see if it's a thing with mammals. And then from there, I'm sure researchers will move on to other critters.
I'm going to call my bird friends. Say, this is something you need to look at. I know you took these measurements last time you were in the field for that last study. Get it done.
Yes.
Scott Brown,
I love it.
Chat room, YouTube chat room, Tiny Humans, OTW, which I think means on the way. Yeah,
Tiny Humans.
So this is, I don't like, how long does that take? I don't know, but if we're going to be in a less water, less resource rich future, we might be seeing smaller humans, and that would be a good thing just for the real estate market alone. If we could just be half our size, we'd have twice as much space.
There you go.
We got to rewrite the Cat Stevens song. Yeah.
I think there's a Dead Kennedy song that I think addresses.
It's gotta be. It's gonna be.
Oh, sure.
Oh, for sure. Oh, and this is This Week in Science. Thank you so much for joining us. If you have not headed over to our website before, click over to TWIS.org at some point and head to our Zazzle store, where we have many items that are wonderful for you to wear, for you to put on your couch, for you to, do we have cat and dog clothes for TWIS yet?
I hope not.
Not yet. I should really look into that.
We should.
No.
Little animal. No, we don't have that yet.
There's
Anyway.
Doormats. You could use that to put your dog or cat balls on top
TWIS
of.
doormats. We've got mouse pads.
Yeah.
Speaking of mice, we've got mouse pads. Yes, our Zazzle store is full of This Week in Science merchandise. It does help to support the show. We hope that you will take a look at our store today. Oh yeah, and subscribe to TWIS, because that's always a good thing to do as well. Click. Hey, do you like the show? Click the like button right now. Okay, we're coming on back. And Justin, it's your turn. What do you have in store?
I gotta check. What am I supposed to be talking about now? I forgot what I was. Forgot what my show was today. Let's see. What did I? Oh, yeah. So this is talking about pollution, as we were segue or two ago. Team of researchers with Ocean Cleanup Project, as well as folks from Wageningen University, both in the Netherlands, sampled over 6,000 hard plastic floating debris items pulled from the North Pacific garbage patch, which, to be clear, it is called a garbage patch, but it covers millions of square kilometers of the ocean's surface. So it's much more of a territory or an island than it is a patch. A patch sounds a little smallish, but that's what they call it. So this floating plastic garbage territory in the ocean has accumulated, due in part because of how surface currents in the ocean swirl and they direct things, and then you've got sort of almost like a Lagrange point in space, if that Lagrange point in space, where all of this debris, floating debris, collects in this one area, and also because somebody has dumped enough floating plastic in the ocean to cover millions of square kilometers. So those two different things working together created this. The sampling was conducted to determine whose plastic is this? Where did this come from? They found that 90% of the identifiable trash swirling around the North Pacific garbage patch comes from just 6 countries. They have published their research in scientific reports. Links on our website available. They looked for words printed on debris as a means for identifying, looking for language, other identifying symbols, including logos. Researchers found that approximately a third of their trash pieces were unidentifiable. They just couldn't, there's no markings whatsoever. They could not even make out what sort of purpose they might have served or where they would have come from, let alone where they would have come from. So then there's a bunch of stuff that they could identify what it was, but there were no markings. They did find that 26% of their haul was fishing equipment based, which is actually a lot higher than I thought it would be. So all this plastic that we're finding in the ocean was used in the ocean at some point, intentionally. Now, this isn't just trash falling off, blowing off a trash barge or something like that. They found plastic buoys and floats were 3% of the objects that they found, but made up 21% of the mass of the material that they collected. Buoys and floats. The researchers were able to identify the country of origin for 232 of the 6,000 objects, which isn't a whole lot, but that's what had identifiable markings on it. The largest percentage being from, what do you think? What's your guess? Anybody got a guess?
United States.
Blair, you want to throw in?
That's what I was going to say.
You're both going to blame the USA.
Yeah.
Well, guess what? Not it.
Really?
Not it. Well, maybe a slight disclaimer here on my saying that here in a minute. It was actually Japan. 33.6% of those objects that they could identify as having an origin were Japan. China was
that
next.
Makes sense because Japan has a really active fishing industry. I would imagine, but it's small compared to China. But then I would also think maybe Norway or Sweden, some of the Scandinavian countries might be.
Well, this is the North Pacific, though.
Yeah.
So I don't know how often they are even allowed to fish over here. So this is going to be all the Pacific Rim job countries.
Yeah.
China was next at 32.3%. And third place was South Korea at 9.9%. U.S. came in, fourth place, 6.5%. And then Taiwan and Canada, 5.6 and 4.7%, respectively. Together, those six countries accounted for over 92% of the identifiable trash found in the North Pacific garbage island. And they think it all comes from fishing jobs. These are like you were pointing out, these are countries that have huge industries of mass fishing that they do out in the Pacific Ocean. And when they're working these jobs, they are apparently losing or abandoning a lot of plastics into the ocean.
I would imagine there would be lots of bumpers, things that get untied and fall overboard, or lines or netting. Yeah, there are all sorts of ways things can end up still floating on the surface.
And now this is the thing, though. This is the thing. A lot of what they found by mass, they think it's going to be 20-something% of the entire garbage patch is going to be these buoys and flotation devices. Yeah. This is stuff that floats.
Mm-hmm. Yeah.
There's probably a lot of stuff that's getting dumped that's not floating, and so it's not accumulating in this location. Well, the one thing I had, the one disclaimer I had on this is,
Not
the United
not
States.
everything can be a shipping container full of floating rubber ducks. But anyway, sorry. Go ahead,
Right.
Justin.
Well, the thing that occurred to me on seeing, China's got 32% of the waste, and the United States has only got 6.5. Gosh, we're much better about not putting plastic in. I'm like trying to picture like how much U.S. language based identifying marks would like. I have this weird feeling that if you went and looked at an American fishing ship and looked at all the buoys and plastics on there, that most of it would have a Chinese or perhaps Japanese marking anyway, as these are major trading partners who are probably
Right.
making a very specific type of product far from the United States shores anyway. So just because the way that they did the identification through language
Yeah.
may not necessarily
accurate.
be but I mean, I like the idea that the U.S. is
Yeah.
just much better about not losing buoys in the ocean and doesn't fish as much. But I don't know if I think that.
Well, I was gonna say that for sure. But the other thing I was thinking about is seafood's probably not the worst contributor to this kind of thing as other food types, but food fished in one country is not always for that country. Like sometimes it's exported, right? So
Yes and no. And this is just a very specific one fish. I only track one fish. I only track one fish in terms of where you can eat, where it's fished, where you can access it, and that's tuna. And you can't get Pacific tuna in Europe.
Right.
Which means you can't get good tuna in Europe. Which is why, like,
well, how are
so
you
different.
rating good? Like delicious or sustainably sourced?
I'm talking about eating.
Yeah,
so
that's the other thing too, is that different markets have different rules for the types of fish that are allowed in their marketplaces, and the United States does not have the most strict seafood rules, unfortunately. But that's also something to keep. I'm just saying, when you're talking about food,
but I think
it does move around. So even if one area is responsible for doing the fishing, that does not mean those are the individuals doing the consuming. And yes, fish is, I would say, transported around the globe probably less, but it still is frozen and moved. So,
I will say from personal experience this summer in Paris, France, the Spanish waiter at a restaurant I went to said, No, it's no good. When we said, how is the fish? How is the salmon? He said,
no,
I would not get it.
So
the Spanish in Paris say no to the salmon.
Yeah, sure.
But I think with I'm talking bluefin tuna is the North Pacific. It's a very controlled,
and it is endangered, actually.
And it's very controlled. And I think it is probably U.S. policy that they don't get sold to Europe. Europe ends up with some skipjack nonsense, some Mediterranean
sustainable,
maybe, but it's not. You're like, why even bother? Just leave them there.
Well, then don't eat an endangered species.
But they're so good.
The more endangered they are, the more delicious they are. That's what some people think.
And then speaking about
Go ahead. I was going to say not to talk about the morals or the ethics of sustainable fishing at this point.
Yeah, that's a whole show.
That's a whole nother thing.
Sorry, I said the S word.
I'm all for everything that's the right thing to do, except when it comes to the bluefin tuna, then I don't care.
Okay, all right.
Because that's the thing I want to keep having there. Make everybody else an idea. I should have like a carve out that I can see.
All right. Okay.
Cravings. Speaking of food cravings for fatty foods are often thought to be taste related. You eat the fatty food thing of your favorite choice, and the buds on your tongue rejoice in celebration. The more butter, the more better it tastes. But research investigating the source of our appetites has uncovered an entirely new connection, an entirely new pathway between gut and brain, driving our desire for fatty foods. Columbia's Zuckerman Institute scientists studying mice found that fat entering the intestines triggers a signal conducted along nerves to the brain, and that this signal drives a desire for fatty foods. It's really fascinating discovery here, because what they did is they took mice and they made it so that the mice couldn't taste what they were eating. And even when they could taste what they were eating, they would go after the fatty foods. The studies published in Nature, link available on our website. It raises the possibility of interfering with gut-brain connection to help prevent unhealthy choices and address the global health crisis caused by overeating of fatty type foods. According to Dr. Zucker, professor of biochemistry, molecular biophysics, and neuroscience, could not stop studying and getting degrees in things. Columbia. Our research is showing that the tongue tells our brain what we like, such as things that taste sweet, salty, or fat. The gut, however, tells our brain what we want, what we need. Blocking the ability to taste in mice. So mice were offered bottles of water with dissolved fats, including a component of soybean oil, and bottles of water containing sweet substances known to affect the taste buds, is the yummy, sugary stuff. The rodents developed a strong preference over a couple of days for the fatty water. They then they formed this preference again when scientists used genetically modified mice to remove the animal's ability to taste fat using their tongues. So even when they couldn't taste that there was fat in that bottle of water, they still switched their preference away from the sugary tasting water to this fat water over time. Even though the animals could not taste fat, they were nevertheless driven to consume it, said Dr. Zucker, who again probably doesn't talk that way. The researchers reasoned that fat must be activating specific brain circuits, driving the animal's behavioral response to these fats. The search for that circuit, first author Mengtong Li, measured brain activity in mice while giving the animals fat. Neurons in one particular region of the brainstem, the caudal nucleus of the solitary tract. I bet you didn't even know that existed.
Oh, I've heard of it before, yeah.
She studies brains.
The caudal nucleus of the solitary tract perked up when there was fat involved. This is intriguing because this has also been a system implicated in previous discoveries as the neural basis for sugar preference. Dr. Li then found the communication lines that carried the messages to the caudal nucleus of the solitary tract, neurons in the vagus nerve. Bet you didn't know you had one of those. Well,
I think a lot of people have heard of the vagus nerve.
Yeah.
So the vagus nerve, which is linking the gut to the brain, also, it says here at least, twittered with activity when mice had fat in their intestines. Having identified the biological machinery underlying the mouse's preference for fat, Dr. Li next took a close look at the gut itself, specifically the endothelial cells lining the intestines. She found two groups of cells that were sending signals to the vagal neurons in response to fat. And this is quoting her here, Mingtong Li. One group of cells functions as a general sensor of essential nutrients, responding not only to fat, but also to sugars and amino acids. The other group responds only to fat, potentially helping the brain distinguish fats from other substances in the gut. And Dr. Li, she goes one step further, blocking the activity of these cells using a drug, shutting down signaling from either group, prevented vagal neurons from responding to fat in the intestines. And guess what? The mice lost their appetite and preference for fats. So, after all this research, what it turns out is it seems to be like there's a bit of a, a feedback loop that is
Yeah.
taking place here also. But that it's not your tongue that's running that's so attracted to this, which is great, because that means potentially, this is not in the study at all, this is Justin alone, if if diabetes is occurs through sugar consumption, you should be able to satiate your obesity with fatty foods that don't have sugar in them. You should be able to have a high fat, low sugar, no sugar diet and still maintain those cravings. Now, that doesn't solve obesity. That's a
Right.
whole other thing. But again, this is a short term where we have the future, the idealized, and then you got the what you can do right now out of your kitchen kind of a scenario. Anyway,
Yeah. I mean, I think that understanding how the gut and the brain communicate, I think the tongue is involved for those kind of instant reactions to what is in your food. This, and the tastes before you get it into your gut, kind of helping you choose the foods that you're eating to know for sure. But then once it gets in the gut, then there's really that conversation going on of we are getting the nutrients we need. No, we're not. Are we really? Yes. No, we need more fat. Get us more fat. And the gut talks to the brain and the brain talks to the gut. And there's this big conversation going back and forth. And it's, if it were simple, we would have figured it all out a long time ago. But it's a very complex conversation, a little handshake that's happening right there. But yeah, hopefully one day
well,
we can
I figured
use
it out.
this information to be able to treat things like metabolic disease, like diabetes, to help if we have targets for receptors, if we have,
Yeah.
if we know how to if we know how to intercept that communication, maybe we can make them, maybe we can send coded messages to the brain from the gut.
Yeah, that's what I'm saying. That's what I was thinking. Like, if
Yeah.
you just hid fat in a diet
Right.
without the sugar, you might be able to. Avoid eating too much sugar that way. But what
All
you
of
were
the
saying,
all of the
you kind of broke up
yeah.
there. But you were saying something about the long time we were looking at it. The gut brain connection, in terms of scientific history, is relatively new, right? This is like just a thing that's just sort of come up onto the radar. That's getting a
No, I mean,
lot of study.
we've known that the Vegas has been involved for a while. But yeah, I mean, we've known that there has been this big conversation happening that I mean, the gut and the brain communicate, but we haven't known exactly where these cells are. We don't know what the cells are that are involved. We don't know the exact mechanisms, but we do know that there are these pathways that that deal with our satiety and our appetites.
Yeah, and that was also the sort of the interesting thing in this study is the way they were able to shut down specific nerve circuits
That's
in
cool.
order
Yeah.
to isolate. Doing gene knockout stuff with the mice to get them to only be able to have this sort of binary approach to their choices, their selections, to being able to narrow down the cell circuits that they could also shut down to then test again after. Like, the amount of resolution on this study that was available was, I think, it's just amazing what they're able to accomplish.
I have some stories related to the brain
Oh,
if we want to stay on the brain for a little bit
Yes,
longer.
please.
Yeah. Well, let's talk first about a study published in Science about the axolotls.
Yes.
axolotl.
We love the axolotls, and Blair, you have talked about how amazing axolotls are because they're regenerative,
Yes.
and we study the axolotls because maybe they could be this wonderful model for human
Yeah.
regeneration. Maybe we can learn how to regenerate our limbs and all these things, and maybe even our brains.
Yes, please.
What?
Yeah, this study published in Science entitled Single Cell Analyses of Axolotl Telencephalon Organization, Neurogenesis and Regeneration. regeneration being the key phrase here, in that the axolotl, Ambystoma mexicanum, is able to regenerate parts of its telencephalon. And so hopefully these researchers are going to discover how the axolotl brain does its amazing feat of regeneration, and that'll help us with brain regeneration of our own, or maybe even
Concussion repair, right? Like,
yeah.
now we've gone full circle with the whole show that we did.
Yeah, that's
This could be
great.
used for all those people suffering from traumatic brain injury.
Right. From the concussions, maybe one day we will be able to regenerate a little bit of our brains. And so they were able to conclude that the post-embryonic axolotl telencephalon neurogenesis progresses through diverse neuroblast progenitors. Blah, blah, blah. They're associated with specific neuron types and dependent on shared as well as specific regulatory programs. And implementation of these same programs were involved in regenerative neurogenesis, indicating brain injury activates the birth of new cells in the axolotl brain through these pathways that are already there. So injury stimulates recovery, but not just fixing the problem, but actually regenerating cells that have been lost. And these regenerated neurons in the axolotls reestablish their previous connections to distant brain regions, which is one of the big things. So we always wonder, okay, we've got all these cells and they're connected to all the other cells in the brain, and what happens if you get rid of a few? Like, what happens to those connections? Well, apparently there are the programs in place in the axolotl brain to allow functional recovery, which is, it's mind-boggling to a degree.
That's amazing.
It's amazing.
So we have so many ailments that includes just parts of our brain going, and it would be great to be able to just kind of give it a tune-up.
Yeah, and that's what you're saying there too. Is I even just it's such a complex system. It's like, what can you do if you could just cut out a section of brain and regenerate it? Just start over. None of this repair. Let's see if we can make this connection better or get rid of this garbage that's building up or whatever. Just, you know what? Let's start over. We'll get rid of this whole swath of brain over here and just regrow it, and you can have like a fresh new bit of brain to work with. That sounds very appealing.
Fresh bit of brain.
Until eventually you replace the whole thing, and then even are you the same person anymore?
Who cares? I want to live forever now too.
These
you
connections and everything's working right. Sure, it's great.
Me. I want to live forever now too.
Yeah.
Wait. I have a question now.
Now that the science is getting better, right?
Because I have a question about axolotls.
Yeah.
Aren't they like an intermediate form of something? Like, they're not like
they are salamanders that essentially continued to look like young salamanders look.
Okay, so
they're running around
still in any. This isn't like an XYZ salamander in a transition state, and we call them axolotls and pay attention to.
No.
They're one that is evolutionarily.
They're a species that stopped growing. So it's like if there was a type of bird that never got their nice feathers and they were covered in down for their entire lives. They were fluffy little chicks.
Humans never got bigger than a 3-year-old.
Right.
Okay. That makes
it's our nymph.
Yeah,
and that's what
the difference is that salamanders go through metamorphosis. So it's more similar to a frog that stays as a tadpole for their whole life.
Okay.
Or I guess it would be more specifically like a frog that gets its legs but keeps the tail. Would be more similar, I think, to what this situation is, because young salamanders have gills, exposed gills, and so these exposed gills just don't go away when they they just stop there.
Yeah, but that makes, whereas some salamanders, like like tiger salamanders and others, are able to are amphibious, where they're able to live in the water, and then on the land, the axolotls are, because of their gills, they're stuck to the water. So it's a different life choice, but
And so other
they've
salamanders can have a stage where they look like axolotls?
Yes.
Kinda. Okay.
yes.
That makes better sense than that.
Yeah, but axolotls, they're amazing. And
They're
now
so
we
cool.
find out that they not only can regrow their tails and their arms and their legs, but they
Wild.
can also regrow their brain cells. And we need to know more.
Super awesome.
Super awesome. Yes. So now, since it is getting into fall, and Blair's, I know how much you love stories related to seasonal daylight changes.
Yes.
I just wanted to throw in a story here at the end about how we're learning more about how day length changes your brain and then your behavior. Every animal who is exposed to daylight and nighttime, we are affected by light. Our circadian rhythms rule our metabolism. Our circadian rhythms rule so much about how we live and how healthily we can live. And researchers at UCSD decided to take a look at, and they published in Science Advances, a mouse model to figure out exactly what neurons switch up the expression of neurotransmitters when day length changes. So when they're stuck with shorter days, what happened to the mouse brain and what exactly changed in there? And what they discovered is that we know that there's an area in the brain that is connected to the optic nerves. It's called the suprachiasmatic nucleus. The suprachiasmatic nucleus we've talked about before. It's very important in the sensing of the light, production of melatonin. It's the body's timekeeper, and it keeps those it's the body's clock. It makes those circadian rhythms go. It's the captain timekeeper on top of everything else. And so when it receives less light from the environment, there are neurons within the suprachiasmatic nucleus, which then change their behavior. And so they determined that there is another nucleus called the paraventricular nucleus, which is also involved in stress, metabolism, growth, reproduction, your immune system, and how you're just everything important pretty much. And they discovered that they could manipulate these paraventricular nuclei that are in the hypothalamus by the light that was added to the suprachiasmatic nucleus. And you know what the new neurotransmitter was? Dopamine. Dopamine, the neurotransmitter that makes you want to do things.
Hey, bud. Dopamine. There he
is. That's right. And so they revealed, according to the first author, Alexander Porca, a member of the Dolkis lab at UCSD, we revealed novel molecular adaptations of the SCN-PVN network in response to day length in adjusting hypothalic function and daily behavior. And so this, for the first time, might show the anatomical functional link that mediates the seasonal changes in mood, and that actually can help mediate those effects of light therapy. So when people have seasonal affective disorder and use light therapy to impact their mood and create happier, better moods, it could be through this particular pathway, and that maybe it is this pathway that is dysfunctional or doesn't respond with the appropriate dopamine levels to keep your moods at a high enough level to just want to do anything when winter hits.
I can't today because winter.
Because winter. I'm sorry. I can't. Winter is a coming in. Yeah. So anyway, our brains, we are connected to, we are very connected to our environments. We like to think that we're humans. We can do what we want. But we learn more and more about how our environments affect us. And so there are these questions of things like how blue light is affecting us, and how too much blue light at night might be impacting our circadian rhythms, and how there's a study also recently that it could be affecting aging, and that too much blue light could be aging us prematurely because it's affecting our circadian clocks in a negative manner. But it's not just our metabolism. It's also, can lead to can have mental health impacts. And so if we understand how neurotransmitters are involved, hey, maybe we can start to manage that stuff a little bit better. But maybe it's going to have to do with the cannabis that you were talking about at the beginning of the show, Justin.
Well, I also just like the idea of recognizing that your employees, your students, your loved ones might be less productive in the winter.
Yeah, and that there is actually a physical change, that we are set up to have lower dopamine levels, have different changed activity levels because of the change in day length. Yeah.
Well, and it's to keep you safe. Like your body doesn't want you going outside in the cold. Like your body wants you to conserve energy and survive the winter. So like,
don't get eaten by a wolf.
Pushing up against that realization that we once lived in the wild. Like we still have physiology that is used to living in the wild and has expectations for us based on that.
And when you say we once, too,
yes,
we're not even really talking about like all
That
of human
long ago?
civilization since that has changed. We're talking about the invention of the electric light.
Yes.
Maybe a reliable source of an oil lamp, something like that. We're talking about a couple hundred years where we've been moving away from just living based on the sun.
There's a reason you want to go to sleep when it's dark outside.
Yeah.
There's a reason you don't feel all active and ready to get out and go places when it's really dark outside. And this is part of it. So, understanding.
So no one should be expected to work for all of December or January. Okay.
I'm fine with that. Let's do it.
Hey, we can still at least take off that 6 weeks I've been recommending. There's still a pandemic. Nobody cares.
No, nobody cares.
6 weeks.
Nobody cares.
Y'all stop getting it.
Boosters are approved. Let's get those boosters, everybody.
Everyone go get your booster.
Get your flu shot. It's probably going to be a bad flu year. Get your COVID booster. These are things that will help you. Yeah, let's reduce severe illness. We can do that.
That'd be great.
Oh,
Anik saying, actually, I do feel active when it's dark out, but especially when the full moon is out. Yeah, Anik said, but
that's a whole
you might be a werewolf.
No, and the full moon actually does increase activity. That's a thing. So that totally tracks.
I have a thing too. It's my whole life been a little bit of a night owl. It's somewhere around after 10 o'clock at night. No matter what my sleep pattern has been, I get it like this burst of energy to go and do. That's when my dopamine kicks in and says, let's go do something.
That sounds like a very young child who missed their nap. You missed your sleep window and then you're like, boo!
Yeah, it's very much like that. Yeah. And then a few hours later, usually it's gone.
There you go.
Just gone.
To wait for the next cycle.
Yeah. Anyway, have we done it? Is it time for us to be tired and be less motivated at this moment for the show?
Time for sleep.
It is time for us to end the show. I really do want to say thank you to everyone. Thanks for joining us. Thanks for a good show. Thanks for making this whole thing possible. Thank you specifically to Fada for all your help with show notes and show descriptions over on YouTube, and for social media, Gord and Gord and Aranlore and others who keep the chat room a happy, kind place to be. Thank you for being there and managing that as well. Identity 4, thank you for recording the show. And Rachel, thank you for editing. And I especially would like to give some shout outs to our Patreon sponsors. Thank you to Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, Ralph E. Philip Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody MS, Chris Wozniak, Dave Bunn, Vigard, Chefstad, Hal Snyder, Jonathan Stiles, a.k.a. John Styler, John Lee, Ali Coffin, Gaurav Sharma, Reagan, Derek Schmidt, Don Mundus, Stephen Alberon, Del Myshak, Stu Pollock, Andrew Swanson, Fredis 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, Brian Carrington, David E. Youngblood, Matt Bass, Vote Beto for Texas, John McKee, Greg Riley, Marquez and Flo, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rapping, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E. Oak, Edda Mishkan, Kevin Parishan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Summerly, Patrick Pecoraro, Tony Steele, and Jason Roberts. Thank you, all of you, for your support on Patreon. And if anyone out there wants me to read their name in this list, well, you can head over to twis.org and click on the Patreon link. And on next week's show, we are going to be joined by a special guest. We'll be speaking with Brian Nelson about his new book, Flush: Science of Toilets and Public Sanitation. It's going to be awesome.
That's great.
That's going to be Wednesday, 8 p.m. Pacific time. You can find it, we'll be broadcasting live from YouTube and Facebook channels and from twis.org/live.
Hey, want to listen to us as a podcast? Maybe as you go on your early morning walk in the summer because it's light out. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twis.org.
You can also contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twis.org. Just be sure to put TWIS, TWIS, in that subject line, or your email will be spam filtered into the deep dark winter when we will be too apathetic to even look at it.
Oh gosh. Yeah, the future's going to be great. You can also keep up or hit us up on the Twitter where we are at TwistScience, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.